Dear student, today I am going to discuss from the chapter 1 chemical reactions and equations on the topic chemical reactions, its characteristics, chemical equations and balanced chemical equations. In the earlier classes, you have learned about the physical sense and chemical sense. In our day-to-day life, we have seen so many chemical changes. Like milk is converted into the curd, iron is rusted, grapes get fermented, food is cooked, food get digested in our body, we respire. These are all chemical changes. All this can happen only due to the chemical reactions. So we can say that chemical change is the chemical reaction. Let's see some examples of chemical reactions. This is then chemical reactions. This is initial substance and this is formed after the chemical changes. So these are final substance. These initial substance are called reactants and final substance are called product. This arrow indicate the formation of product and these are coefficient. Here also one coefficient. This is another chemical reactions. Magnesium burn in air and it form the magnesium oxide. So this magnesium and oxygens are reactants and magnesium oxide is the product. We can do an activity to burn a magnesium ribbon for the formation of magnesium oxide. Before the burning, we have to clean the magnesium ribbon with a sandpaper. Why? Magnesium ribbon already react with the oxygen or carbon dioxide from the atmosphere from a oxide or carbonate layer on the surface of the magnesium ribbon. That is why we have to clean first. Next, see how can we burn a magnesium ribbon in air. See, after burning the magnesium ribbon, we can get a glazing white powder of magnesium oxide. Now, we are going to discuss about the characteristics of chemical reaction. To be a chemical reaction, there must be some characteristics. It shows change in state, change in color, and change in temperature, evolution of gas, etc. We can do an activity to show the change in state, change in color and formation of precipitate also. For this, we can do the activity. Let's see the activity. To show the change in state and change in color, we can do the activity. First, we have to take the lead nitrate. This is the lead nitrate salt, and we have to prepare the aqueous solutions of lead nitrate. See, this is a colorless salt. Then we add into a test tube. Then add water into it. Keep it for dissolving. Next, take another test tube. For the potassium iodide solutions, take first. This is an potassium iodide. See, this is also a colorless salt. Take, this is also colorless salt. Add water into it. and dissolve. After then see, these two are the colorless salt solutions. Both are colorless salt solution. You see, you can take the equal proportion also. After then, if you mix both of them, then you see the one colored solution, one insoluble substance, that means solid substance, form in the aqueous solution. What happened in this reaction? First of all, we have take the lead nitrate, then add the potassium iodide. So after reaction of lead nitrate and potassium iodide, it forms the lead iodide of yellow precipitate or yellow insoluble substance or yellow solid substance in the aqueous potassium nitrate solution. So this way we can show the change in state also, that means solid substance is formed, and it show the change in color also. Next, to show the evolution of gas, we can do another activity also. For this, we can do the activity like a way. First of all, we have to take another test tube. Take this test tube. This is a boiling tube. And add water for cleaning. Then add the sulfuric acid to it. This is a dilute sulfuric acid. Then we have to add the zinc granule. That means we are making the reaction between zinc granule, zinc with the dilute sulfuric acid. So this is a zinc granule. You see. Then take 2-3 pieces of zinc granule and add to the dilute sulfuric acid. And close the mouth of the test tube with a cork containing the delivery tube. See the reactions. There is the evolution of gases. That is why we can find a bubble, and when this gases is passed through the delivery tube, and if we pass through the soap water, then this bubble formed from the soap water goes upward, and if we bring the light and matchstick, then it will give the pop sound. This indicates the presence of formation of hydrogen gas. That means after the reaction between zinc and sulfuric acid, it formed the zinc sulfate and hydrogen gas. So this was the evolution of gas. This way we can show the change in temperature also. In some reaction there is a change in temperature also. It may be increase in temperature. If in a reaction there is an increase in temperature, that means release of heat, this is called the exothermic reactions. Like when we bring the calcium oxide from the market and add the water, then it forms the calcium hydroxide, which is called the slag lime. In this reaction, if we touch the beaker, then we feel the heat. That means there is an increase in temperature. This is an example of exothermic reactions. Again, if we bring the limestone, then heat it, then it forms the calcium oxide and carbon dioxide. In this case, since heat is required to break down the calcium carbonate to form the calcium oxide and carbon dioxide, so this is then example of endothermic reaction. Means there is a absorption of heat. So the reaction in which heat is evolved, this is called the exothermic reaction, and the reaction in which heat is absorbed, such type of reaction is called the endothermic reaction. Dear students, we will continue next the topic, the chemical equation